everyone. Today we have to learn integration by partial fraction. Mean to say we have to integrate the function type of fx gx dx, where fx upon gx is what? It's a rational function. Rational function can be categorized as the proper and improper. Proper means if degree of fx means numerator is less than degree of gx means denominator. Means the proper rational functions are those functions in which the degree of numerator is lesser than the degree of denominator. And improper rational functions are those if degree of fx means numerator degree is greater than or equal to degree of denominator means gx. That kind of function known as improper rational function. In order to find out the partial fractions, we people has to use the proper rational functions always. If the question comes in improper, then we have to reduce it into the proper, and after then we have to use it for partial fraction. Partial fraction means what? We have to split or we have to divide our function into a small function whose integration can be easily obtained. I repeat, partial fractions means what? It is a process to obtain that given integrand or given function into a small piece of portions which is easily integrable. In that process, first of all, I am taking the first kind of function, where the denominator, I am talking about the case first, fx upon gx, where gx equals to, I am taking the first case first, gx is completely factorized and having non-repeated roots, non-repeated factors. That I mean to say. In such cases, the case number one, that is easy one, completely factorized and having non-repeated factors. In this case, the question comes like that. Here is, say, the question comes x minus 1 dx upon x minus 2 and x minus 3, like that. We can see in this integrand portion the denominator is completely factorized and it is proper also. So we are able to do the partial fraction. How we can do? So we have to isolate this integrand portion first, and then we have to resolve the partial fraction method. I'm just doing the partial fraction. How we can do? Just see. First of all, I should consider a point A, variable A, along with the very first factor. Say it is x minus 2. Again plus the next point we have to consider B along with the second factor, that is x minus 3. If there is 3 factors, we have to consider the third one, say C it is, and it is continue, and we have to consider that much variables as the factors involved in the denominator concerned. We have to keep in touch, our denominator should be completely factorized and should not have a repeating factor. Fine. After then, we have to take the LCM portion, that is x minus 2 and x minus 3. Here is A and leaves here x minus 3 and plus of B, here is x minus 2. In the left hand side, it is x minus 1, x minus 2 and x minus 3. While we comparing both the sides, then denominator is still same. So numerator should equals to A of x minus 3 plus B of x minus 2. This one defined as identity. Identity means it will hold for any value of x. We can substitute any real quantity there. So we have to substitute. How many values we have to substitute? Number one question is there. The answer is we have to substitute as much the values as the variable involved. Mean to say, if we are using 2 variables, then 2 values should be substituted. If there is 3 variables, then 3 values should be substituted. Number one. Number two question arises, what value we have to substitute? So question is there. So answer is, what the factor you have? You have x minus 3, you have x minus 2. So we are able to get the values by putting them 0. If I am placing it 0, then x comes to us 3. If I am placing this 0 as x comes to us 2. So we can substitute 2 and 3. We can substitute any value, any real number, but for easiness or for quickness, we are able to put them. So we have to substitute, say, x equals to 2 very first in both the sides. I already told you people that is identity. We are able to put any value in place of x. So here is x equals to 2. In left hand side 2 minus 1. In right hand side a 2 minus 3, and this portion become 0. So there is 1 equals to minus of a. So a come to us minus 1. So in place of a, I am able to put minus 1. After then, again I have to substitute one more thing, and that part will be x equals to 3. Fine. In the same relation, I have to substitute x equals to 3 in both the sides. In left hand side again, this is 3 minus 1. In right hand side, that portion is 3 minus 3, and there is b, and again 3 minus of 2. And then we have to simplify. There is 2. In right hand side it becomes 0, and it will be b. So we have the result b equals to 2. Now both the results with us. Now we are able to integrate our portion. So finally we have the expression x minus 1 upon x minus 2 and x minus 3, that equals to what? A upon x minus 2 and b upon x minus 3. In place of a, we have to substitute the result. The result is minus 1. Here is. In place of b, we have to place the value of the result is 1, and there is x minus 3. Here is x minus 1, x minus 2 and x minus 3. We have to substitute the component. So it is 2. Correct. Now we are able to integrate. If I wish to integrate that, x minus 1, x minus 2 and what? X minus 3. In the right hand portion, there is minus 1 upon x minus 2 dx, and it is 2 will be out, and again dx upon x minus 3. And here is minus 1 still out, and integration is dx upon x minus 2, and here is the differentiation of denominator comes in numerator. So I am able to write that directly. Integration is at log of x minus 3. The same thing I should use here. So this will be minus of log of x minus 2 plus of 2 log of x minus 3, and plus some constant of integration c. There is the portion we have. So that is the first method we have, how we can do the partial fraction, and by using that we are able to integrate individual of them. That is the first one. Another example, we have dx upon x minus 1 whole square x minus 2 dx. That's it. In this question we can see on the integrand portion, the denominator part x minus 1 is repeating its root. So that is the case where the factor repeated itself. So we have to partial fraction it. How we can do that? Just see. Here is the integrand portion. Now first of all, what should I say? We have to consider a variable a along with the single power of that factor. First x minus 1, and next one again a variable b along with the repeated power of that factor, that means square. If it is q, then we should consider one more variable, and we should consider that q part also. But if it is not there, then we should go ahead, and next one is c along with the third part is x minus 2. Now we should take the LCM first. There is x minus 1 whole square and x minus 2. Now here is a, and we have to write x minus 1 and one more factor is x minus 2 plus of b, x minus 1 whole square as such. So in place of that we have to write x minus 2 and plus c. Here is x minus 1 whole square. In the left hand side it is 1 upon x minus 1 whole square x minus 2. Now we have to compare both sides. There is 1 a x minus 1 into x minus 2 plus of b x minus 2 and plus of c x minus 1 whole square. Again it creates an identity, and our job is to find out value of a, b and c. These are three variables, so we are supposed to put their three values. Out of them, if we are placing 0 of this factor, then I have x equal to 1. By using this, I have x equals to 2. So two values we can substitute, and one more value we have to put here. So let's see. Here is first, let x equals to 1 first of all. So after substituting that, what will happen? If I am putting 1, left hand side is still 1, it is 1. In right hand side, while we are having 1 here, 1 minus 1 become 0. So this entire portion will be 0. So left over with b, here is 1 minus 2, and this portion also 0. So there is b equals to minus b, and finally b equals to minus 1. That is our first part. Now again we should consider next value. Say it is x equals to 2. So while we are placing x equals to 2, then what will happen? Again, I have to substitute this value in this identity. While we are putting that, then see, in this portion, if x equals to 2 comes, then it will be 0. In this portion, x equals to 2, it will be 0, and then it is leaves over. So 1 equals to c, and it is 2 minus 1 square. And now we have to put it again. So here is b equals to minus 1 just in a corner. There is 1 equals to c is there, 2 minus 1, 1. So leaves there, c equals to 1. That's it. Now b and c, both the values we have. We are in need of one more value. So one more value we have to substitute here. And what should be that? Now it depends on our liberty. I am going to place here 0. Just for convenience, nothing else. You can substitute any else. So third value we are considering here, x equals to 0. In left hand side, it is 1. In right hand side, here is a. There is 0, 0 minus 1. This is minus 1. Again, it is minus 2. Now it is 0. That is minus 2b. It is 0. This is plus of c. So there is 1. It becomes now 2a minus of 2b plus of c. This is an equation in a, b and c. Out of them, b and c are familiar for us. We should substitute them. So 1 equals to a is what? We have to calculate. B is what? Minus 1. It becomes plus 2. C is plus of 1. Now we have to find out a. Say it is 1 equals to 3 plus of 2a. 3 should be there. Minus 2 equals to 2a. And a equals to minus of 1. Now we have all the three values. This one. These are a, b, c we have. Now we can conclude our integration portion. So initially, now our question is 1 upon x minus 1 square, x minus 2, that was a upon x minus 1 plus b upon x minus 1 whole square plus c upon x minus 2. That was. Now we have to substitute the value. So in place of a, there is minus 1. In place of b, there is also minus 1. And in place of c, we have to substitute plus 1 upon this one. That is the value, and this is the partial fraction. Now further, we are proceeding for integration. If I have to do integration of that part, x minus 1 square and x minus 2, then what should I do? I should integrate parallelly all of these components. So there is minus out, here is dx upon x minus 1, minus out, here is dx upon x minus 1 whole square, and finally here is dx upon x minus 2. Now all the components are integrable easily, and we can conclude our result. Here is minus, the differentiation of denominator lies in the numerator, so I can directly quote it, log of x minus 1. Here is 1 upon x minus 1 square, so integration will be what? Minus is there, minus 1 upon x minus 1, and here is the differentiation of denominator lying in the numerator. So I can say again it is log of x minus 2 plus of c. So that is the conclusion for this problem. So in this problem we are doing partial fraction as well as integration. That is second kind. In case of third kind portion, or you can say third type of problem, the denominator part, we are having a problem like this. See, dx upon x square plus 1, and here is x minus 1. In such type of problem, there is a part which is non-factorizable, and this is factorizable. So in that course, how we can proceed? Just see, there is 1 upon x square plus 1 and x minus 1. First of all, I should consider that factorized component. Say it is a along with what? X minus 1. Now I should consider the next one. The next component is non-factorized. We are not able to do the real factorization of that. So what we have to do, we have to put it with the special consideration. What the special consideration? In the numerator, in place of a normal variable, we should write a linear expression. We should write a linear expression, say like this, bx plus c along with that non-factorized component. That is the treatment of non-factorized components everywhere, every time. If one more non-factorized component occurs here, then I should consider one more linear expression along with that component. Now again we have to take the LCM portion, that is x minus 1, here is x square plus 1. Right, here is a, inside part is x square plus 1 plus of bx plus c and what? X minus 1. In the left hand side, it is x square plus 1 and x minus 1. We should compare it, and after comparison, we are having an identity. So there is the identity for us. So this is the identity. Now our job is to find out the values, and now we have three variables a, b and c, and we have to substitute three values at least for that. One value we can find out by using this. If we are placing it 0, we are having x equals to 1. So first of all, we should place x equal to 1. So here it is. So x equals to 1 here is, left hand side it is 1. Now it is x equals to 1. 1 square 1 plus 1 2. That becomes 2a. Now 1 minus 1 is 0, and due to that entire portion is 0, and a will come out for us, that is a equals to half. That's the first value we have. Now for next value, we have to consider one more value. We can substitute x equals to 2. We can substitute x equals to minus 1. We can substitute any else. But I am considering here the value x equals to 0. You can put it also. So there is 1 in the left hand side. In right hand side, this is 0. A into 1, it is a. And plus, now in place of x, we have to substitute 0. So while we are putting 0, that part will be 0. Then c is there only. And x will be 0 and minus 1 is there. That's it. So 1 equals to a minus of c. A portion we have, we can substitute that and c will be out. So 1 equals to 1 by 2 minus of c. And then after, we can write the value of a in the left corner for the reference. Now c we have to calculate. Here is c equals to, that will be half of minus 1. C equals to minus 1 by 2. So two values we have. Again c equals to minus half we have. Now we have to calculate one more thing. Again, a value of b is still pending. So one more value is needed. So we have to put one more value. So what should we put? Next we can put any else. Say let x equals to 2 we have. Fine, in the left as well as right. So there is 1. If we are putting 2, that becomes 2 square plus 2 square means 4. 4 plus 1, 5. So there is a 5a. Plus of, it is 2b plus of c, and here is 2 minus 1, 1. So it will be as such. There is a 1. So there is 1 equals to 5a plus of 2b plus of c. Now we can substitute these two values here in place of a and c. So there is 1 in place of a, I am putting 1 by 2. In place of b, we have to calculate. In place of c, there is 1 by 2. So just simplify. 5 by 2 minus 1 by 2. It becomes what? 4 by 2, that means 2. And plus of 2b. We can transport that. So 2b equals to minus 1. And b again come to us what? Half. Minus half. So here is the value of b, that again is minus half. So in the same pattern, we are able to get the value of a, b and c. And we did the job for partial fraction. Now it's a time for integration. How we can do integration? Just see. Previously the question was 1 upon x square plus 1 and what? X minus 1. And the portion was a upon x minus 1 plus bx plus c upon x square plus 1. Now it's a time for just replacing all the values. We have to substitute all the results here. In place of a, there is a half. 1 upon x minus 1. In place of b, I should put minus half. So it is minus x by 2 plus c is again minus 1 by 2 and divided by x square plus 1. So that is the value of this. Now we have to integrate. So dx upon x square plus 1 and x minus 1. And we have to put it again. So in place of that, we should write it. A will out. Integration of dx upon x minus 1. So why will it say a? That should be half. Fine. And next one is this portion. Minus of. Minus will be common in both of them. 1 by 2 is common in both of them. So x plus 1 leaves here upon x square plus 1 along with what? Dx. Simple. Now we have to integrate that thoroughly. So finally, for conclusion, we have to integrate, and the integration portion is 1 by 2. The differentiation of denominator lies in the numerator. So we can write directly here log of that. So log of x minus 1 on base e. That part is over. In this portion, what I'm going to This minus half is there. Take the bracket. Just isolate the numerator individually. So I'm writing here x upon x square plus 1 integration with the dx, and one more plus 1 upon x square plus 1 dx. So these two integrations here. Now we have to integrate them. So there is half, log is still there, mod of x minus 1 e minus of. Now see, if you are doing the differentiation of that portion, the differentiation comes 2x and numerator is only x. So we should multiply with 2 and divide with 2 and multiply with 2. So there is 1 by 4 integration 2x dx upon x square plus 1. Why I am doing so? Because if the differentiation of denominator occurs in the numerator, I can write directly log of with the denominator. That's why we did it. Minus sign, inside move, there is minus half and dx upon x square plus 1. And that is the conclusion. 1 by 2 log of x minus 1 mod of e minus, now it's able to do differentiation of denominator lying in the numerator. We are able to put the log here. So log of x square plus 1 and minus 1 by 2. It's a simple case of tan inverse x plus of c. That is the integration of that, and we did it with the help of partial fraction. Thank you.